Good day everyone. Today I will solve a third order differential equation using the Laplace transform method. The given equation is y triple prime plus 3y double prime plus 3y prime plus y is equals to t cubed with initial conditions of y of 0 is equal to 3, y of prime of 0 is equal to 1, and y double prime of 0 is equal to 0. This type of equation is difficult to solve directly, so we use Laplace transform to convert it into an algebraic equation, which is easier to handle. So the first step is we apply the Laplace transform. We take the Laplace transform of both sides. That would be the Laplace of y triple prime plus 3y double prime plus 3y prime plus y is equal to the Laplace transform of t cubed. And we expand the Laplace on the left side and we take the Laplace on the right side. That would be the Laplace of y triple prime plus the Laplace of 3y double prime plus the Laplace of 3y prime plus the Laplace of y is equal to the Laplace of t cubed is equal to 6 all over s raised to 4. And by using the standard formulas, we take the Laplace on the left side. That would be s cubed Laplace of y minus s squared y of 0 minus s y prime of 0 minus y double prime of 0 plus 3. The Laplace of y double prime is s squared Laplace of y minus s y of 0 minus y prime of 0 plus 3. The Laplace of y prime is s Laplace of y minus y of 0 plus the Laplace of y is equal to 6 all over s raised to 4. And we simplify further by using or substituting the initial conditions. That would be s cubed Laplace of y minus s squared 3 minus s, the initial condition 1 minus 0 plus 3 s squared Laplace of y minus s multiplied to 3 minus 1 plus 3 s Laplace of y minus 3 plus Laplace of y is equal to 6 all over s raised to 4. And we simplify it further. That would be s cubed Laplace of y minus 3s squared minus s plus 3s squared Laplace of y minus 9s minus 3 plus 3s Laplace of y minus 9 plus Laplace of y is equal to 6 all over s raised to 4. And we simplify it further. That would be the Laplace of y, the quantity of s cubed plus 3s squared plus 3s plus 1 is equal to, we transpose it to the other side, the other terms, that will be 6 all over s raised to 4 plus 3s squared plus s plus 9s plus 3 plus 9. We simplify further the right side of the whole equation. That will be the Laplace of y, s cubed plus 3s squared plus 3s plus 1 is equal to 6 all over s raised to 4 plus 3s squared plus 10s because of 9s plus s plus 12 because of 3 plus 9. We simplify it further the right side by making the whole equation into one denominator, and that would be the s raised to 4. That would be the Laplace of y, the quantity of s cubed plus 3s squared plus 3s plus 1 is equal to s raised to 4 divided by s raised to 4 multiplied to 6 is 6. S raised to 4 divided by s raised to 4 multiplied to 3s squared is 3s raised to 6 plus s raised to 4 multiplied to 10s is 10s raised to 5 plus 12 multiplied to s raised to 4 is 12s raised to 4 all over s raised to 4. And we divide the whole equation by the quantity on the left side to get the Laplace of y. That would be the Laplace of y, s cubed plus 3s squared plus 3s plus 1 is equal to 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 all over s raised to 4. We divide it by the quantity on the left side, that is the s cubed plus 3s squared plus 3s plus 1. And we'll get the Laplace of y is equal to 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 all over s raised to 4 multiplied to s cubed plus 3s squared plus 3s plus 1. Now we simplify it further, as we need to simplify the denominator. That would be the Laplace of y is equal to 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 all over s raised to 4 multiplied to s plus 1 multiplied to s squared plus 2s plus 1. And we simplify it further. That would be the Laplace of y is equal to 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 all over s raised to 4 multiplied to s plus 1 multiplied it again to s plus 1 squared, and as you can see that would be s plus 1 cubed. So our Laplace of y now is equal to 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 all over s raised to 4 multiplied to s plus 1 cube. So we break the equation by applying partial fraction decomposition. So first is we transpose to the other side the Laplace. That would be y is equal to the inverse Laplace of 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 all over s raised to 4 multiplied to s plus 1 cube is equal to the inverse Laplace of a all over s plus b all over s squared plus c all over s cubed plus d all over s raised to 4 plus e all over s plus 1 plus f all over s plus 1 squared plus g all over the quantity of s plus 1 cubed. Now we multiply the whole equation by the denominator on the left side so that it will be easier for us to handle the equation. So we multiply the whole equation by s raised to 4, the quantity of s plus 1 cube. That would be that would be 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 is equal to a s cubed multiplied to s plus 1 cubed plus b s squared multiplied to s plus 1 cubed plus c multiplied to s plus 1 cubed plus d s plus 1 cubed plus e s plus 1 cubed multiplied to s raised to 4 plus f multiplied to s plus 1 multiplied to s raised to 4 plus g multiplied to s raised to 4. Now, by simplifying it further, we wait that we write the whole equation. So now, by simplifying it further, our whole equation is 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 is equal to a s raised to 6 plus 3s raised to 5 plus 3s raised to 4 plus s raised to 3 plus b s raised to 5 plus 3s raised to 4 plus 3s raised to 3 plus s squared plus c, that would be s raised to 4 plus 3s cubed plus 3s squared plus s plus d s cubed plus 3s squared plus 3s plus 1 plus e, that would be s raised to 6 plus 2s raised to 5 plus s raised to 4 plus f s raised to 5 plus s raised to 4 plus g s raised to 4. Now we multiply the variables to simplify it further. That would be 6 plus 3s raised to 6 plus 10s raised to 5 plus 12s raised to 4 is equal to as raised to 6 plus 3a raised to 5 plus 3as raised to 4 plus as cubed plus bs raised to 5 plus 3bs raised to 4 plus 3bs cubed plus bs squared plus cs raised to 4 plus 3s cubed plus 3s squared plus cs plus bs cubed plus 3ds squared plus 3ds plus d plus es raised to 6 plus 2es raised to 5 plus es raised to 4 plus fs raised to 5 plus fs raised to 4 plus gs raised to 4. Now we get the value of a to g. As you noticed in our equation, there is an s plus 1 in whole equation other than letter g. So we use if s is equal to negative 1. Our whole equation now is 6 plus 3 multiplied to negative 1 raised to 6 plus 10 multiplied to negative 1 raised to 5 plus 12 multiplied to negative 1 raised to 4 is equal to g multiplied to negative 1 raised to 4. That would be 6 plus 3 minus 10 plus 12 is equal to g. G now is equal to 11. So we get the equation of s raised to 6, that would be 3, is equal to a plus e. By altering or manipulating the equation, our e is equal to 3 minus a. That would be our equation 1. By using s raised to 5, that would be 10 is equal to 3a plus b plus 2e plus f. That would be equation 2. By using s raised to 4, that would be 12 is equal to 3a plus 3b plus c plus e plus f plus g. But as we all know that g now is 11, so we substitute it to the equation. That would be 12 is equal to 3a plus 3b plus c plus e plus f plus 11. And we transpose the 11 to the other side. The whole equation now would be 1 is equal to 3a plus 3b plus c plus e plus f. That would be our equation 3. We write the whole equation. So this is our third equation. By using the s cube, That would be 0 is equal to a plus 3b plus 3c plus d. That will be our equation 4, our fourth equation. By using now the s squared, that would be 0 is equal to b plus 3c plus 3d, and that would be our fifth equation. By using s, that would be 0 is equal to c plus d. We manipulate the equation, that would be d is equal to negative c, and that would be our sixth equation, our equation 6. Now we substitute equation 1 to equation 2. That would be 3a plus b plus 2 multiplied to 3 minus a plus f is equal to 10. The equation now is 3a plus b plus 6 minus 2a plus f is equal to 10. The equation now is a plus b plus f is equal to 4, and that would be our equation 7. Now we substitute again the equation 1, and the value of g is equal to 11 to equation 3. That would be 3a plus 3b plus c plus the quantity 3a minus a plus f plus 11 is equal to 12. That is 3a plus 3b plus c plus 3 minus a plus f is equal to 1. That will be 2a plus 3b plus c plus f is equal to negative 2. And that would be our equation number 8. Next, is we substitute equation 6 to equation 4. That would be a plus 3b plus 3c minus c is equal to 0. And our equation now is a plus 3b plus 2c is equal to 0. And that will be our equation number 9. Next, we'll use substitute equation 6 to equation 5, and that would be b plus 3c plus 3 multiplied to negative c is equal to 0, and that now would be b plus 3c minus 3c is equal to 0. Now our b is equal to 0. Next, we substitute the value of b is equal to 0 to equation 7. That would be a plus 0 plus f is equal to 4. A plus f now is equal to 4. By manipulating the equation, f is equal to 4 minus a. That would be our equation number 10. We substitute the value of b and number 10, the equation 10, to equation 8. That would be 2a plus 3 multiplied to 0 plus c plus the quantity 4 minus a is equal to negative 2. Now, our equation is 2a plus c plus 4 minus a is equal to negative 2. A plus c now is equal to negative 6. That would be our equation number 11. Now, we substitute the value of p is equal to 0 to equation 9. And that would be a plus 3 multiplied to 0 plus 2c is equal to 0. A plus 2c now is equal to 0. A is equal to negative 2c. And that would be our equation 12. We substitute equation 12 to equation 11. That would be negative 2c plus c is equal to negative 6. Negative c now is equal to negative 6. The value of our c is equal to 6. Now, we substitute c is equal to 6 to equation 12. A is equal to negative 2 multiplied to 6. A now is equal to negative 12. We substitute the value of A to equation 10. That would be F is equal to 4 minus the quantity negative 12. That would be F is equal to 16. Now we substitute the value of C to equation 6. That would be 6 is equal to negative D. D now is equal to negative 6. Next is we substitute the value of A to equation 1. E is equal to 3 minus 12. E is now equal to 15. To summarize the value of A to G, A is equal to negative 12. B is equal to 0, C is equal to 6, D is equal to negative 6, E is equal to 15, F is equal to 16, and G is equal to 11. Now by substituting the value of A to G to our partial fraction, so we will be the inverse of negative 12 all over s plus 0 all over s squared plus 6 all over s cubed minus 6 all over s raised to 4 plus 15 all over s plus 1 plus 16 all over s plus 1 squared plus 11 all over the quantity s plus 1 cube. Our y now is equal to negative 12 plus 6 t squared all over 2 minus 6t cubed all over 6 plus 15 e raised to negative t plus 16 e raised to negative t plus 11 e raised to negative t squared all over 2. By simplifying our equation, y is equal to negative 12 plus 3t squared minus t cubed plus e raised to negative t multiplied to the quantity of 15 plus 16 e raised to 16t plus 11 all over 2 t squared and that is our final answer. Now to summarize our solution, first is we applied the Laplace transform to convert the ordinary differential equation to algebraic form. And next, we substitute the initial conditions. We solve for y of s, and we use partial fractions. We applied inverse Laplace to get the y's of t, which is negative 12 plus 3t squared minus t cubed plus 15 e raised to negative t plus 16 e raised to negative t plus 11 t squared all over 2 e raised to t. This method is very powerful because it simplifies solving higher order differential equations, especially with initial conditions.